Hi everyone! Today we're going to talk about the sum of squares. Oh no, not this type, not the Pythagorean theorem. We're going to talk about 1 squared plus 2 squared plus 3 squared, on and on till n squared. A lot of you may have heard about a formula, and some of you may have proved it through induction, just by assuming that it works for n equals 1 and then just continuing for n equals 2, n equals 3. But today we're going to give an actual rigorous proof and find the formula. So let's get started. First, we're going to start by using the fact that a cubed minus a minus 1 cubed is equal to a minus 1 times a squared plus a minus 1 plus a minus 1 squared. This is just a simple difference of cubes, a cubed minus b cubed factorization. So just by simplifying some terms, we get 1 times a squared plus a squared minus a plus a squared minus 2a plus 1, which just simplifying is 3a squared minus 3a plus 1. So we can now use this and start by using n cubed. So we say n cubed minus n minus 1 cubed is equal to 3n squared minus 3n plus 1. N minus 1 cubed minus n minus 2 cubed is equal to 3 times n minus 1 squared minus 3n minus 1 plus 1. Now, it might not seem like we're going to reach anywhere, but you can notice that this might create a telescoping sum if we continue like this. So if we use n minus 2 cubed minus n minus 3 cubed, then all of these terms, if we add up the left sides and the right sides, they're all going to cancel out, as we will soon see. So we can just repeat this process all the way till 1 cubed minus 0 cubed is equal to 3 times 1 squared minus 3 times 1 plus 1. So, assuming now we can just sum this up. So we can sum all of the left side and all of the right side up to get that, because this will cancel out. The n minus 1 cubes will cancel out because we subtract it once and then we add it back. And then in the second line, we subtract n minus 2 cubed, and in the third line, we add n minus 2 cubed. And so this will all cancel out. And if we just cancel all the terms, at the end, we'll get n 0 cubed is equal to 3n squared. 3n squared plus 3n minus 1 squared plus 3 times 1 squared minus 3n plus 3n minus 1 and then add back of 1 plus 1 plus 1 . So we're now going to use sigma notation because we're all sigmas like that, and we're going to get that n cubed is equal to 3 times the sigma of I equals 1 to n of I squared. This is just saying 3 times 1 squared plus 3 times 2 squared, on, minus 3 times the sigma of I equals 1 to n of just I, plus sigma I equals 1 to n of 1. So there are some simplifications we can create here, because this is n cubed, right? We're going to leave this term, the first term of the sum of squares, alone for now, because this is actually what we're trying to find. See, this is 1 squared plus 2 squared plus 3 squared. So if we figure out like what this term means, and we can find it in terms of the other things that we already know, then we can figure out what just the sigma of I equals 1 to n of I squared is. So that we'll come to later. But this is 3 times n plus 1 over 2, because that's what the formula is for the sum of the first n integer, plus n. So now isolating this term on the one side and moving everything to the other side, we get n cubed plus 3n squared plus 3n over 2 minus n over all over 3 is actually just equal to what we're trying to find. I equals 1 to n of I squared, or if you prefer seeing it this way, it's 1 squared, 2 squared, n squared. So now to figure out what this actually is, well, we can just do some simplifications, take everything over, we can make a common denominator of 6. We get 2n cubed plus 3n squared plus 3n minus 2n all over 2, and then the overall denominator. So we put a common denominator of 2 in the numerator equals, we're just going to simplify this a bit, 2n cubed plus 3n squared plus n all over 6. And this is the formula for the sum of squares. Now, you might have seen it in a different form. So some people have seen it like this. I'm just going to list a few different forms. Some people might have seen it like this, n cubed over 3 plus n squared over 2 plus n over 6. Or it's also, if you just factor it, if you factor the numerator, you can find that this is actually equal to this. Okay, because the cube term is going to be 2 times 1 times 1, n squared. The squared term is going to be n squared plus 2n squared, so it's 3n squared. And the n term is just going to be n times 1 times 1. So these are two other ways that are more common. And this is although this is the most common one, we're going to be using this one because it helps with our later generalizations. So now that we have done sum of squares, we will do sum of cubes. So same thing. It's not like a cubed plus b cubed, which there is already a formula for, but we're going to do 1 cubed plus 2 cubed, on till n cubed. And you will find, I'm going to share a fact about the final formula, and you will find it quite surprising. It's pretty interesting, but that we will come to later. So we start the same way. We take a to the fourth minus a minus 1 to the fourth equals, instead of factoring like last time, we're going to use binomial expansion. So this is just equal to a to the fourth minus, in parentheses, a to the fourth minus 4a cubed plus 6a squared minus 4a plus 1. And so now we write this a to the fourth minus a to the fourth plus 4a cubed minus 6a squared plus 4a minus 1. So this is looking familiar. The a to the fourth terms cancel out, and so we're left with 4a cubed minus 6a squared plus 4a minus 1. So we are actually going to repeat this whole thing again, just like how we took a telescoping sum in this whole part and we added everything up. We're going to do the same thing, but with fourth powers. So I'm just going to rewrite this so we know where we are. A to the fourth minus a minus 1 to the fourth is equal to 4a cubed minus 6a squared plus 4a minus 1. This is also So now we do a minus 1 to the fourth minus a minus 2 to the fourth equals 5 is equal to 4 times a minus 1 cubed minus 6 times a minus 1 squared plus 4 a minus 1 minus 1. So I'm not going to continue more. I'm just going to put, because we already know what to do. So this is equal to 4 times 1 cubed minus 6 times 1 squared plus 4 times 1 minus 1. So, like last time, these can all, we take the telescoping sum on one side, and the other side, it will have another, we can represent it again using sigma notation. But again, we're all sigmas, we're just cool like that. So much aura, bro. So what we're going to do is we're going to take all this and we're going to then do a to the fourth minus 0 to the fourth is equal to 4 times a cubed plus a minus 1 cubed dot 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 minus 6 times a squared plus a minus 1 squared dot dot dot, which, as you notice, we already know how to calculate the inside part. We just proved it. And so that will be actually really helpful when it comes to, again, moving everything onto one side. So next we have 4 a plus a minus 1 dot dot dot, and finally plus, actually this time it is minus 1. It's minus 1 plus 1 plus 1 plus 1 dot dot dot. And so next we're going to now do a little bit of sigma notation, but less than last time. So this is equal to 4 times sum of cubes, which is actually exactly what we wanted to find. So that is going to be very helpful. Minus 6 times, this is sum of squares. So we can replace it with our formula, which we just found. Actually, I'm not going to use this one because this one will mess up our final calculation. So this one I'm going to use, again, the n cubed over 3 plus n squared over 2 plus n over 6. And then we're going to take plus 4 times n squared plus n over 2, and again, minus n. So moving everything other than the sigma to one side, we get, oh, actually, sorry. I'm going to replace a with n because our variables have been using n instead of a so far. So now we have n here. So we now get that n to the fourth plus. So now we're going to focus on this part and simplify that so we can move it to the other side, right? So now we have 2n cubed plus 3n squared plus n. And now we have to subtract. So 2n squared minus 2n. And then we finally add back n. So this time we actually have no fractions in the denominator. So that's very nice. So we can just proceed and simplify this and divide by 4 at the end. So I'm just going to write this for reference. So you get n to the fourth plus 2n cubed plus this time it is actually only 1n squared. And there are no n terms because there's minus 2n and there's plus n plus n. So if there is no n term, then that makes it a very interesting calculation. So this is then just equal to the sum of cubes. So finally, lastly, this is our answer, but we're going to write it in different forms again because they could be helpful. And there's a neat thing about the sum of cubes. So this is equal to n to the fourth over 4 plus n cubed over 2 plus n squared over 4. But this is also equal to, if you notice this, we can factor out an n squared and n squared plus 2n plus 1 out of it over 2 squared, which this is actually equal to n times n plus 1 over 2 whole squared. So sometimes it's represented in this factored form. I'm going to represent, so this one has an extra form because it has such a nice relation with the sum of just the natural numbers up till n. It is that sum squared. It's n times n plus 1 over 2 all squared. I know, right? It's so cool. And there is no obvious connection to this. There actually is no reason it should be this, but it just is. And that's how the math works out. That's so cool, right? Like, it's so genius. So that's our final answer. I'm gonna write it as how we're gonna use the final formula because that's what we really want to use. So we're gonna write it like this: n to the 4th over 4 plus my numbers plus n cubed over 2 plus n squared over 4. Okay, that was for our video today. Watch out for my next video, because next time we're going to generalize this to 1 to the k plus 2 to the k plus 3 to the k till n to the k equals what? What could this equal? There is no really intuitive way of thinking about it, so I'm going to go through some steps to get us closer to the final solution, but not to the actual solution. So watch out for my next video. See you next time.